So today I'm going to talk a little bit about Shio, which is a Scala API for Google Cloud Dataflow. And I just flew in after a 12-hour flight and jet lag. And I'm going to do like live coding demo. So what could possibly go wrong, right? So who am I? I'm Neville. I work at Spotify, been there for 4.5 years. I mostly work on data infra for machine learning and analytics. I work with a team that built Discover Weekly and related artists and playlist recommendations, among other things. I work a lot with big data frameworks like Scouting, Spark, Storm, and right now I'm working a lot on Google Cloud since probably the past year and a half. So a little bit origin story. At Spotify, we've been using Scouting for machine learning recommendations for a while, since 2013. And so about almost 3 years now. And a few people are picking up Spark for machine learning as well, ad hoc mostly, and exploratory research kind of use cases. Right now, there are like 50 plus users writing Scala code. Most of them are from a data science background, so very little actual computing or like computer science programming experience. And well, actually, we got a lot done with Scala. We have 400 plus unique jobs every day, unique pipelines, and probably thousands of them running daily. So it's a lot of processing with Scala. And early last year, we started moving to Google Cloud. It's been secret for a while, and we just announced it like a few days ago, I think, last week, that officially we're moving to Google Cloud. Right now, there's actually a GCP Next 16 conference happening in San Francisco right now at PITA 48. Today is day 1, and tomorrow I'm going to talk again at that conference about how we use Dataflow and Scala. But that one's more like a high-level business-ish talk, and this one will be a bit more technical. I hope I can demo more of the actual code in this project. Anyway, it started as a hack project, Dataflow Scala, because we like the Dataflow model. It's really nice. I'm going to talk about the model a bit later, but we also like Scala, so we want to have a Scala API for it. So what is a Dataflow? Google introduced this idea like 2 years ago from the Millwall paper, which basically unifies batch and streaming processing. If you're into like big data frameworks, Flink also has a similar model that unifies the two. It has a direct runner which runs locally on your laptop, so you can do like testing, development very easily. It also has a Dataflow runner which runs on the Google Cloud instances, and it's fully managed, which means you don't have to like set up your own cluster, do a lot of scripting, operational stuff. You just basically run the main method of your job, and then we'll send up some requests to the cloud, and it sets up the cluster, and it does auto scaling even, like scaling up and down the cluster as needed. So that's very nice. Also, people have been building other runners for it. So right now, there are like Spark and the Flink runners in work in progress. And also, it's being incubated into Apache, or is being incubated into Apache as a Beam. So basically, the goal is to have this unified SDK that supports all sorts of different execution engines. So we built this hack project, and what's the hardest problem in computer science? Naming things, of course. And because it's a Scala framework, what do you call it? That's the first version. Because you need an S in Dataflow, so where to put it? It's better than Satanflow, right? Just kidding. So we call it Shio. Actually, a coworker who's Italian came up with this name because it's Latin, and ecclesiastical Latin, that's like the kind the Pope speaks. Means I know, I understand. Pretty fancy. It's a Scala framework, name of a Scala framework that starts with SC and ends with IO, so totally buzzword compliant. So what is Shio? It is an API on top of Google Cloud Dataflow, and the core API is very similar to Spark core, and also it has some ideas borrowed from Scouting, the two frameworks that we like very much. There's open source on GitHub, and it's open source under Apache license too. So look at other options like we had before. What's the main differences? Why not just run Scouting on GCE? Of course, scouting is very popular. It's used by a lot of companies. It's very mature proven, and it runs on Hadoop, which is also very stable. The downside is you have to manage this Hadoop cluster. At Spotify, right now we have a 2,300 node cluster, the largest in Europe, and it goes down a lot very often. It's always overloaded because of the amount of data we have. And it takes a team of maybe 5-10 engineers to just keep it up, and a lot of like late night calls with Hortonworks or whichever your Hadoop vendor is. And it doesn't handle multi-tenancy that well. I mean, it could be overloaded during the weekdays, and you have very low utilization over the weekend. There's also no streaming mode in scouting. Well, Twitter has the summing board. You can say that, but it runs on top of Hadoop and Storm. So basically, you have to maintain 2 different clusters, and it's just another API that's probably less popular than scouting itself. So it's not something that we've investigated into. Well, at Spotify, we do use Storm, but so far we've only been using the very basic Java API. So there's also Spark. Spark runs nicely on GCE. You can set up clusters pretty quickly, and it supports batch and streaming mode. On top of that, it also has interactive and a SQL query. It also has a lot of libraries for doing machine learning and graph processing. It even support a lot of different languages. Well, the downside is people who've tried Spark at scale, there are a lot of tuning parameters. There are like hundreds of knobs to tune. And right now, like the Hadoop cluster we have, we're running Yarn, and to run Spark on Yarn is just very, very hard to scale up because of the resource contention. I mean, it is easier to run it on cloud like AWS or Google Cloud. Like you can just spin up VMs and set up your cluster. But then you have to do all the lifecycle management. Like if you run one cluster per job, you have to make sure they tear down, or if something goes wrong, then you have to look into it. A lot of operational cost. So that's why we looked into Dataflow and Scala. Dataflow, I mean, the pros we already talked about. It's a managed service. There's no operational cost. So when you run a job, you can run it from your laptop. Say, give me 50 machines, and it will send a request to the cloud, spin up all the VMs, and does auto scaling under the hood. It has a built-in integration with all the other products in Google ecosystem. Some of them are already like pretty proven, a bit like BigQuery. It's the system that inspired a lot of other SQL Hadoop kind of systems, and it's Google's been using it internally for like more than 10 years, so it's very reliable. It's also like systems like Bigtable, and there's also a simple unified model for batch and streaming, which I'll talk a little bit about later. And of course, the Dataflow SDK is in Java, and it's a very simple API. Basically, you have a collection like a P collection, which is a parallel collection, and have one type of operation called doFn, which is basically a flat map. Of course, people from a Scala world are used to have all these, nice high-level transforms, like filter, group by, all sorts of things, and that's why we built it. And then you have all these reusable components, transformations, codes, FP style code that you can reuse. There are also nice Scala libraries for doing like machine learning, numerical computation, like Breeze, which is kind of similar to NumPy, and also Algebra, a Twitter library for doing like a lot of the parallel processing, approximation algorithms and stuff. Very nice. So this is the typical word count example in Shio. If you've done Spark before, you can see that the code is almost exactly the same. Even Shio context, I mean, the variable, the value name is just SC. It's what I call a copy-pastable. Of course, this is a Google library, so we have to show a PageRank algorithm. It's very simple. You have a collection of source and destination links. You initialize PageRank to 1.0, and then over 10 iterations, you redistribute the rank, and then do some dampening factor. And that's it, in 13 lines of code. And there's some fundamental differences, so mostly in the data model. For example, in Spark, there's RDD for batch, and then the Spark streaming is actually a slightly different model called dstream, which is a sequence of micro batches or sequence of RDDs. So the API there actually has two sets of API that are slightly different. Spark also has in-memory caching mechanism. Dataflow, on the hand, has a single P collection, which does both batch and streaming. So in batch, you basically have a collection of items that you process, all or nothing. And then in streaming mode, the items in the P collection are actually windowed into based on timestamps. So operations like group by and reduce or whatever operate on a window by window basis. And you have the same API on both batch and streaming, which is really nice. So you can write your job and then test it on a log file using the timestamp from the log lines as a window mechanism. And then you can just deploy the job with a data pub/sub input, which is a real-time streaming input. Then you have your streaming job. So that's a very nice feature for Dataflow. Next, execution. That's also very different. There's also a very different, big difference between the two. In Spark, there's always a master node and a bunch of workers. So basically, the master or the driver drives the operation on the workers. That's how you get this dynamic execution. And also, in Spark, for example, there are concepts called transformation and actions. Transformation basically happens only on the workers. Each worker processes on its own, or transfer data, doing shuffling and whatnot a bit among themselves. Whereas the action will actually take data from the workers and back to the master, and the master have the ability to decide what to do next. In Dataflow and Edge scouting to some extent, there is no master node. So once you write your job, it basically determines a static execution graph and it submits to the cloud, and then you can just shut down your laptop. There's no driver whatsoever. It runs on itself. On the downside, there's no action. Basically, you have to, and there's no dynamic execution. Basically, you have to determine or to design what you want to do in the job ahead of time. So that's a slight difference between the two. So what do we get from the Scala API? The Shio API, of course, you have Scala. And I also added features from algebra, like you can do sum and aggregate if you are familiar with those concepts. Those are very popular for scouting people. And also added type-safe BigQuery with Scala macros, which I'm going to demo in a bit. And interactive repo, which also going to demo. And then last, every time you save something into disk or data store, whatever storage engine in Shio basically returns a future of a tab, something that you can reopen in the future. So that basically replaces some of the missing features, like in Dataflow, like the fact that it's a static execution and there's no interactive mode. This make up for that. So the last two. Yeah, demo time. Let's see how it works. Can everyone see is it big enough? Okay. So I've built this repo jar here, so I'm just gonna Java run it. Have some parameters basically specifying the project, the Google project, and the data location. In this case, it has to be in European Union because we are Spotify, a European company. And this is real data, not sample data. All right, now you have this interactive repo. Kind of looks like Spark. I mean, it's sort of borrowed a lot of the ideas. All right, so what do we do? A typical word count. I have a cheat sheet, so I'm just gonna copy everything from here.
Can you please bring the prompt to the mid screen so folks can see better?
Oh, okay. So if I do this, is it better? Yeah? Okay. So what I'm doing here, SC is a context I get for free when I start a repo, text file like in Spark, flat map. You have a text file into a collection of lines, do a split by whatever non-alphabet character, convert to lowercase, filter out the empty ones, do a count by value. Now you have a tuple 2 of string and long. Materialize basically save it to some temporary location that you don't need to care about, but you can read it back. And it returns the future, so that's the F1. It returns a future of a tab of the type of my computation, string and long. Nothing happens here because I haven't submitted my job yet. And I'm using the local runner by default. So if I do a close, yeah, that will actually kick off the job in local computation. Direct pipeline runner, which means it runs locally. Now I have a result, res1, it's complete. Because it's local, so it completes right away. What do I have with the future? What can I do with it? Of course, you can wait for results. Res3, it's the tab. Tab basically encapsulates something I have on disk or in some storage, BigQuery or whatever that I can open later. So I can just do value, which gives me an iterator. Take, I don't know, 10 for each, print 10. That's your result. What else can you do with the tab? You can open it in a second pipeline. So I have this magic keyword called new shield, which gives me a new context, a new copy of the SC. So remember that every SC context correlates to a single unique job. So you get a new one for the new pipeline. The plus side is you can have multiple jobs running async in parallel, and then you can join the futures. Things like that. So now I'm just gonna copy the code because I'm terrible at typing. So the first one I did a basic work on. The second one I'm gonna assign this res3 to t, which represents my tab. Now I paste the code here. So basically I'm saying, given this tab, I wanna open it in a new context, filter by count greater than 5, materialize to some other temporary location. Okay, sc.close. Now my F2 is complete. Wait for result. You know the drill. So value for take 5 maybe for each, print 10. Now you have it. So I mean this could technically run in the cloud as well, which I'm gonna show in a bit. But I'm going to show the most exciting feature, or at least the one that I'm most fond of. So here's your typical BigQuery. There's a BigQuery client built in as BQ, so you can like read and write BigQuery tables. So let's say I want to get rows from this BigQuery table, which is a real table, by the way. So we can go back to this table detail in BigQuery UI. This is all track level metadata of a track in Spotify. So you have all these content tags from music labels. Econest, that's a company that we acquired that does music intelligence. So all these derived data, hundreds of fields. And this is a moderate size table of 448 gig, 64 million rows. Decent size. So I can say get rows, give me, some tracks from a particular date. It doesn't really load everything to memory. It's a lazy iterator, so it gives me like iterator over the rows. Of course, you do next to fetch one row. Because the way BigQuery works, everything is JSON, so a glorified map of string to objects, everything is object. So I can do res9 dot, let's see what I want to get, master metadata. So I have to type it. And of course, I am terrible at typing, so you get a null. Imagine in the production pipeline, it will run for 2 hours and, null exception. Of course, now what does it give me? Object. I have to cast it into instance or something that I think it is. So table row, so on and so forth. Basically a lot of trial and error. And let's say I want to get track, another object. Yeah, pretty boring, right? The next example I'm going to show is a BigQuery macro, which actually uses the Scala macro provider feature. Basically, I can generate code at compile time. So let's say this guy here from query. And where's my query? So I'm going to paste this decent sized query here. Basically selects a lot of columns, which I don't know the type yet. But BigQuery already knows because, I mean, the schema is in the BigQuery table definition. So why do I have to specify the type again? I shouldn't have to, right? So I call it class TE, track entity, because I'm too lazy to type. So it generates all these classes, case classes, which are totally type safe. So what can I do with this case class? I can convert JSON into it, right? So instead of doing the previous version, the whichever version I was doing, this guy here, this guy gives me JSON, and I don't want a JSON. I want case classes, so I can do bq.get typed rows TE. Do I have to enter the query again? No, because the query is already in the type. It's in the companion object. It performs a BigQuery in the background. Now it gives me an iterator. This query is pretty fast. Well, actually, it's already cached. So it caches the temporary result in the temporary table. So I get a, get an iterator right away. Now I do, what do I do next? Well, TE equals to this. Now I can do all these things like master metadata. Okay, it's an option. I know it has value, so I'm just gonna do the get. You know, what do I want to get next? Track maybe. It's another option because it could be nullable. So get, yeah. And what else in track? Okay, track name. Now I have a track name, totally type safe. And what else can you do with this, with all these options and stuff? Of course, you can do full comprehension. So I'm saying I want to get master metadata and then get track and then get track name. Of course, I want to get audio attributes. And from audio attributes, I want to get a tempo. Now I do a yield. Now I have an option of track and tempo. What else can I do with this? I can put it in a real job. So go back to this guy here. So remember, so far I've been running jobs locally in a local laptop. But this case, I want to run it for real. Did this? No. I'm going to cancel. So I'm going to use this new magic word called geo options or ops. So basically saying, instead of running the default empty options, which implies local, run with this option, say run inside Google Cloud project of this project ID, using this Google Cloud bucket for staging data, and also using the Dataflow runner, which is basically running for real in the cloud. Now I can get a new context, which maps to this new cloud configuration that can run, stuff for real. And then I'm gonna copy that guy over. So type BigQuery gives me a S collection of this case class, and then remember this guy for comparison here, so you can fall into flat mapping into option. So basically filter out the empty ones or whoever that, whichever track that's missing, track name or any of the fields I'm accessing. So like this, right? And then let's say I want a track of a certain tempo. So _2 greater than, let's say 100. Sounds good? Yeah. Then materialize to somewhere in the cloud, I don't care. I hope it works. It works, okay. Now it's time to find out if it really works. So when I do the close, it's gonna submit the job to the cloud. Okay, let's see. It's uploading 3 files to the cloud, which including one for the repo, one for the temporary code I enter inside the console, and some other file that I don't remember what it is, but that's the idea. I'll upload some actual jar files to the cloud, and the cloud, Google Cloud VMs will pick up those jars and execute them. So it gives me a link to the cloud data flow, where I can visualize the flow. So I even included the stack trace of where you're. So if you're running from a Scala file, this will show the file name and the line number. But in this case, it's just a console and whatever magic ID the console uses internally. I'm not really, expert in the compiler. Or basically, it's duct taping everything until it works. But it sort of works pretty well. So I have a job. It's gonna take like a minute or two to spin up the VMs, and then it's gonna give me some result. Meanwhile, we can go back to the slides. So things learned from building a framework. I mean, I like how studying how these things work, like scouting Spark, but it's actually the first time I actually try to build something from scratch myself, and there are a lot to be learned from such experience. Serialization, it's a huge pain. Yes, it's everywhere. It hits you. Yeah. So what Scouting, Spark, Storm, or these other frameworks does is they use Cryo or Chill, which uses a lot of like low-level bytecode technique to serialize things and reflection, which works kind of okay in most cases until you hit weird objects that are not serializable. Then you have to duct tape. Dataflow and Crunch, which is another Java framework written by ex-Googler based on the Flume Java paper, requires explicit coder. So basically, every transformation, every time you do .map, .flatmap, whatever, you have to specify coder, which is pretty painful for the developer, and in a lot of cases, you don't need those coders. Imagine if you do 2 maps in a row. It's going to happen in local machine. There's no need to serialize data, but you still have to specify the serializer. Dataflow does some JVM reflection magic to sort of figure out the coder, but it doesn't always work, which is another pain. So in Scala, we can cheat by having class tags everywhere. It's not pretty, but you can do that sort of reflection and get, whatever that's in your S collection or in your pipeline, and then apply the proper coder or serializer. And of course, you can always fall back to Cryo, which will try its best to serialize things, except when you hit, serialization libraries like Avril or Protobuf, which does all sorts of weird stuff that are just not very serializable. But that's a whole other topic. Closure serialization is even worse. Whenever inside your Lambda you reference something outside, like from the closure, it's gonna screw things up. It's posing everything from your job class or wherever. We use the Chill's closure cleaner, but it doesn't work 100%. There are edge cases where it either fails to clean up certain fields or clean up too much, and you end up with nulls inside your Lambda. And again, it's mostly software engineering, right? Duct taping, making things serializable or transients, until it works. But still some edge cases. REPL is really fun. It took us a bit. Actually, it was written by a coworker who used to be a Hadoop ops, but now that we don't have to maintain the Hadoop cluster anymore, he's freed up and to write actual code. Another nice thing for building things on the cloud. But anyway, so whenever I type in the REPL, right, it has to be serialized, and of course the Scala console doesn't generate class files. So again, hack around so that we hijack the console class loader and then just dump everything in the console current session into some jar file and then ship it to the cloud. The macro type provider, it's really fun. I mean, you're generating code, right? Basically, you have your types tied to the SQL code, and in the same place. You don't have to manage a separate repo or separate build system for like compiling Avril or Protobuf files. And because everything is type safe, if you handle it like in the same way, just handle options with care. I mean, if it compiles, it usually works. It usually works pretty well. It's nice. Also discovered IntelliJ bug. It doesn't understand the generated code from macro, so you have all these red text in IntelliJ because it doesn't realize the fields are being generated. Well, that's why we have the repo. If it works in the repo, it works in real code, right? So maybe not a huge deal. So what's the status right now? A few teams in Spotify are using it already. I mean, we really like the fact that it integrates with all the other Google ecosystem. Like you can read from BigQuery dump to Bigtable. Some teams are already using Bigtable for serving production traffic. So it's nice where you can do all these ETL stuff or whatever data processing without going through your current Hadoop cluster, because our cluster is pretty overloaded. Also want to improve the API and the repo usability. I mean, there are some parts of the API that are not perfect or haven't finalized, so could use some improvements. Of course, we can always use more code and more tests and docs. That's another work in progress. Anyway, it's open source, so feel free to try it out and submit pull requests and issues. Actually, let's go back to this guy here. That's a repo, so it's very simple. The URL is very simple, Spotify/Shio. It's also very easy to remember. sc.io domain name is not registerable, though. Maybe they don't allow like 2-character domain name. But anyway, if you go to releases page, you can actually download the repo jar, which is a self-contained Uber jar with everything, so you can just Java jar it. And you don't need a Google account to run local mode. If you want to try BigQuery, I think BigQuery actually provides some public data sets that are free to query, so you can set it up and just play around those features. Back to the job here. Let's actually look at the graph. Oh, it's done. So this job, let's look at the summary. Took 3 minutes, not too bad. And at each transformation, you can see some basic statistics like number of elements processed and also total size. So pretty nice for troubleshooting. I know the Dataflow guys are adding some more features for like tracking performance, VM stats, and whatnot. But anyway, so now I'm back in the console. Okay. I didn't have to restart the console even once. That's nice. So the nice thing here is like I run a job with 20 workers, for example, and I realize, okay, it's not enough, right? You just change the configuration and run another job with 100 workers. I mean, it will be hard to do in Spark because you have to tear down and set up another cluster. And it will be like close to impossible in Hadoop because I mean, who's going to do that? But anyway, let's see. 21 is complete. It is complete. So where's my result? That's this guy, the future of my result. Wait for result. That's just implicit class with this fancy method. Basically does the future, the weight, whatever. Okay. Value. Maybe not for each. Let's take 10 of them for each. You get some results, pretty nice. If I have another minute or two, I'm going to show some code. Yeah. Window. Some work in progress code. This is a job, it's a work in progress, but basically it does recommendation for running tracks. So we have this feature in Spotify where you can open Spotify and run to the beat. Basically, it will detect the beat, the tempo you're running with, and recommend tracks that you might like that, fall into that beat tempo bucket. It's a simple idea, but basically what we do is have a gigantic BigQuery that selects tracks with certain criteria, energy level, acousticness, whatever criteria, duration, sort of things. And for each track, we have a latent vector from a matrix factorization algorithm that we use for user recommendation. And of course, for each user, we have the same vector, so we can compare the compatibility or taste, likelihood the user likes a particular track. What we do is, do these two gigantic BigQueries, basically selecting everything into memory and do the rest, how to do the stuff, how to do in SQL, in the Scala code. Basically for the tracks, we do a lot of filtering, a lot of duct taping, basic filtering by heuristics or whatever criteria that the data guys came up with. And then group by tracks or artists, basically filter out the less popular ones. Now you have a candidate track, a set of candidate track for each tempo. Let me make it a little bigger. And then for each user, we also fetch the vector of that particular user. So the next, we compute the nearest neighbor, which you can do either brute force by basically doing a matrix multiplication, or you can do any fancy approximation algorithm. We have a library called Annoy which is basically a tree-based or random forest-based nearest neighbor lookup mechanism. In this case, I use LSH, which is locality-sensitive hashing. Basically, build an index for the entire Spotify catalog that are suitable for running, and then for each user, you basically brute force or do the nearest neighbor lookup and generate suitable tracks for running for each bucket, which is a pretty huge data set. Because imagine, I don't know, maybe 30, 40 million active users times 20 tempo buckets times 25 tracks per user. And at the end of the day, you dump everything into some gigantic storage like Bigtable, and then you can serve it, to live traffic. And that's the idea. I'll go back to the slides. So that's the link. We just search for GCP Next 16. There will be more talks. My colleague Igor, we share the same session tomorrow afternoon, but he will talk more about the streaming part of Dataflow and PubSub. I basically cover whatever I talked about just now. And that's it. Questions? Do you have time for questions? Alexei?
Yeah.
Time for questions, yeah. Sure. Yeah?
Please repeat the questions once folks ask.
Yeah, sure.
First question, is this specific to Google Cloud, and how difficult would it be to deploy this in a different platform?
Amazingly, it's not. So, so the question is if it's specifically for Google Cloud. It is actually not. When Google open source Dataflow SDK, it runs on Google Cloud or local mode, like the two modes they provide, but then people built a Spark and Flink runners. And we actually tried the Flink runner. It works sort of out of the box. Of course, it's work in progress, and there's some tweaking needed. But the idea is Google implement all these sources and sinks themselves, which is independent of, if you look at Flink or Spark, they basically rely heavily on the Hadoop library. Basically, they use Hadoop for reading and writing HDFS and whatnot. The Google approach is they abstract away the sources and sinks. So all these Bigtable data store or PubSub sources in and outs, they work in any runner. It's basically a library that fetches. For example, the BigQuery example, it actually just runs the BigQuery in the background using the standard Java API, and then it dumps the query into some flat files, and it reads the files back into your workers. So it can be technically any runner. Yeah.
I had another question.
Yeah.
So in Spark,
Mm-hmm.
I'm trying to compare this with Spark.
Mm-hmm.
So in Spark, you have control over when something is cached in memory or not,
Yeah.
persisted or not,
Yeah.
because you're trying to optimize
Mm-hmm.
memory usage and at the same time performance. So what happens here? It looks like it's not giving us this.
Yeah. It actually doesn't have any caching mechanism. I see them as like solving different use cases. Spark is really good at doing interactive, lookups or exploratory use cases. I mean, the downside is it has to fit in memory. If it doesn't, you run into problems. And also losing a worker causes problem because you basically have to redo all the work. I see Google built this thing to basically solve the problem of building large-scale pipelines that does both batch and streaming, but not really for solving like interactive query kind of use cases, in mind. So that's the major difference. But I mean, there are other ways of doing similar things on Google Cloud. BigQuery is if used wisely, BigQuery can solve a lot of the problems. I mean, right now, even before this, a lot of our users are using BigQuery with basically IPython notebook, and that works to a certain extent, but they solve different problems. Yeah.
I'll ask a question.
Yeah.
So should we just all move to Google Cloud? What's your experience so far?
I mean, Of course, Google started doing this like a few years ago. I mean, they had all these amazing infrastructure for a while. Certain things like BigQuery, Bigtable that they've been using in-house like for more than 10 years, and those are like solid, reliable, and proven. I mean, those work really well. Certain pieces they built from scratch for the cloud product. For example, Dataflow, even though the idea came from Google a few years ago, like whatever they use internally, but Dataflow SDK is actually built from scratch. So there are some rough edges. I mean, that's one thing you need to keep in mind. But of course, Google has like, I don't know, like how many engineers they have, like 15, 30,000. So, I mean, they catch up really fast. Again, and also that's a business decision, right? So moving to cloud means potentially you will be tied to a particular, like in this case, you will be tied to a particular cloud vendor. I mean, depending on if it's something you see as a risk in the long run. Yeah, but of course, if you want to replicate all these amazing features yourself, it's not impossible. It's just really hard. Like BigQuery, you can probably have similar tools, similar setup with Impala or Presto on top of Parquet or whatever, but I don't see them as nice as BigQuery. Not at least not yet.